Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haji Aiman bin Isa and my metric number is 11DKA22F1068. Our group of 4 people consists of me, Amir, Fakrul and also Adam. Today we will present about a case study from the subject of Geotechnical Engineering. The title we got was a phase slope study in Melaka. The location we found in Kampung Gansa, Durian Tunggal, Melaka. The introduction in this study is to explain the occurrence of slope collapse in Kampung Gansa, Melaka. Specifically in this presentation, we will discuss and explain how the slope collapse in Kampung Gansa happened, as well the causes and implications of the incident. Next, we will also identify a design based on British Standard 800-10994 that is suitable to replace the existing slope design. Next, in this slide, we will also explain the factor that affect slope collapse. Finally, this case study will provide suggestions on how to solve the problem of slope collapse with reference to a proven project using any stabilization method. Next, I will explain the type of retaining wall used in the Kampung Gansa. The retaining wall used is a type of shotcrete. Shotcrete is a construction technique that involves spraying concrete or mortar mixture into the surface at high velocity using compressed air. This process is typically used for application where conventional casting or forming methods are impractical or where rapid application of concrete is required. This method allows efficient construction and repair of structures such as wall, tunnel and slope.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noah Merizal Mimat Nazir. My metric number is 11DKA22F1069 and I'm from DKA 3B. So today I'm gonna explain about cause of slope failure we got from our witness. So first cause of slope failure is water saturation, like heavy rainfall. So extensive rainfall can saturate the soil on the slope, increasing its weight and reducing its shear strength. This can lead to landslide, especially in areas with steep slopes. After that, cause number 2 is human activities like excavation. So human activities like excavation, mining or construction can alter the natural slope geometry and reduce its stability. Next is poor drainage. Poor drainage is when improper drainage system, where they can lead to water accumulation, increasing pore pressure and reducing soil stability. Next, and finally, cause of slope failure is vegetation and root system. First is deforestation. Removal of vegetation can reduce the stability of slope as plant roots help bind soil particles together. Deforested areas are more susceptible to corrosion and landslide. Next is overloading. Overloading slope with excess vegetation such as trees with dense canopies can increase the weight on the slope and contribute to failure. Next, I'm gonna explain about new slope protection. Gabions walls are executed mainly in the purpose of soil stabilization behind the wall, but it can also be executed as a cover wall. The wall is made from gabion baskets that are stacked in one or more rows depending on the height of the wall. Baskets can have a K shape and are closed on all sides. They are made from a galvanized hexagonal mix and broken rock that are placed in the baskets. Retaining structures are formed by stacking Gabion basket is a proper schedule and present an alternative solution for concrete structure in the area of soil stabilization.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Adam bin Azmi. My metric number is 11DKA22F1045 and I'm from DKA 3B. Next, I'm going to explain the steps of gabion construction. First, identify the location. The location should be identified first by looking at the site plan and specification so that the position of the gabion that will be built later in is the correct position and meets the specification. Next, clean and level the area. The site or work area must be clean of all rubbish that will interfere with the work of building the gabion later. In addition, a sketched work area can pose various threats to workers. Therefore, to avoid any unsafe incident, the work area should be clean. Next, the gabion cage must be tied firmly. The gabion cage must be firmly tied so that it can accept the load pressure from the stack of stones. The higher the stack of stone, the stronger the pressure of the load on the cage. If the gabion cage is not tied firmly, it may break and collapse and may cause an accident. And last, control gabion level. For gabions that are built lengthwise, the arrangement of stone in the gabion cage should be adjusted to get the same height so that it look more neat and beautiful addition to being able to meet the specifications set in the drawing.
Hi, my name is Muhammad Fakur Biazza and my matrix number is 11DKA22F1016. Now, it's my turn to talk about benefit of gabion wall. First, aesthetics. The gabion walls looks natural and by using natural materials fits the environment. Second, compatibility with the environment. Using materials made by excavation, acquisition and transportation costs are significantly reduced. Third, use as a cooling system in hot climates and provides passive cooling through air movement. Yang keempat, water permeability. Gabion walls are permeable and not damaged by flowing water. Yang kelima, the efficiency of gabion walls can increase over time as vegetation fill the voids and strengthens the wall structure. Yang keenam, ground movement does not negatively affect gabion walls, which is an advantage in terms of more rigid struktur, reinforced concrete walls. Dan yang ketujuh ialah longevity. Stone blocks are frequently used material due to their longevity, durability and stability. Usually, the stone is chosen because of its aesthetic properties or the possible of excavation resulting in the use of the material. Now, I will show you the project that successfully using gabion method that located at section 090 Jalan Malaysia Jeli at Kelantan. In conclusion, addressing the challenge associated with slope failure requires a multi-phase approach that combines scientific understanding, engineering solutions, community engagement, and proactive mitigation strategy. As the frequency and intensity of extreme weather events increase, it becomes even more crucial to prioritize resilience and sustainable practice to reduce the vulnerability of slopes and the community the impact.